Everybody, welcome to Echo Live. My name is Anna, and of course I'm coming to you from the Michigan Science Center. I hope that everybody had a great weekend and a happy Monday. And today we're going to be talking about a really cool new topic here on Echo Live. I'm going to teach you the science of ice cream and hopefully show you how you can make your very own delicious ice cream snack at home using a couple really simple ingredients and doing some pretty amazing science all at the same time. Now, we are making ice cream today in celebration of summer being not over just yet. So I know that I'm holding on to my last little bit of summer, even though most of us are back to school, whether that's in person or virtually. Summer is still here for another one full week. And so I figure what better way to celebrate our last little bit of official summer, at least summer in the scientific world, than by making a pretty delicious summertime treat. Now, if you haven't done so already, feel free to introduce yourself in the chat feature wherever you are tuning in live from. Hello to Owen in West Michigan, tuning in here on Facebook. Hi to everyone joining us on YouTube. You can use that chat feature, as always, to ask questions throughout the program, to make suggestions, or to introduce yourself and chat with some of our friends. So good to see so many of us joining in, even though school has been back for a couple of weeks, I think, for a few of us. Hi, Jasmine. Good to see ya. All right, now I have everything you'll need to make your own at-home ice cream right here on this side of the table. Some of these things you probably already have in your home if you like to bake, like I do. I will say I'm not good at baking, but I do like to do it because it's kind of like doing science that you get to eat. Now, everything you'll need is right over here. To make your own at-home ice cream, turn my camera just a little bit, all you'll need is whole milk, or some sort of milk substitute, but we'll talk about the issues that come up with that. So you'll need whole milk, heavy whipping cream, sugar, vanilla extract, some various measuring cups and things like that, and sea salt, or coarse salt works best for this. Now, I think until I got over here, everything so far sounded pretty good, right? We know that ice cream is called ice cream, right? Because it's usually made out of some combination of milk and dairy products. You might know that milk and heavy cream mixed together is also what we call half and half. And so you can always substitute half and half for these ingredients that we'll use as we move through our experiment here together. Sugar tastes pretty good. Vanilla is the flavor that I've chosen for our ice cream here because it's pretty simple. Most people have vanilla extract if you like to make cookies or anything like that. But what in the world could we be doing with sea salt? That doesn't sound very good. Not definitely something that I would commonly think about adding into ice cream. But the sea salt is going to be very important when we get to the actual scientific process that's going on, that's going to help us turn these ingredients that we have right here into ice cream. Now, my first question for all of you tuning in is, what state of matter do you consider ice cream to be? Right? We've talked a lot about our states of matter on past episodes of Echo Live. We've dedicated entire episodes to even just one state of matter. And so I'm curious to hear what you think, because maybe there's not just one right answer to that. If you had to pick whether ice cream was a solid, a liquid, a gas, or plasma, our very fun, awesome fourth state of matter, which of those would you pick? Now, I definitely think of ice cream in a few different forms, right? I know that you can get kind of like twisty cones of ice cream at McDonald's or other ice cream places, and that stuff's pretty soft. But you can also get hard scooped ice cream from something like an ice cream store, or maybe something more similar to what you would buy at the grocery store to bring home. You can't really bring soft serve home with you and keep it in your freezer. So tell me what you think. What do you think? What would you consider to be the correct state of matter if you were classifying ice cream? Lots of friends starting to tune in the chat. I see a great question from Maureen. So while you think about our states of matter, Maureen asked, will our demos continue after next week? Yes. Don't worry, Echo Live is going to keep happening through the rest of the year and hopefully throughout all of next year too. We have no plans to stop doing these demonstrations, but you might know that our summer schedule is coming to an end. So instead of taking place on Tuesdays and Thursdays, after the official start to fall, which is coming up next week, we are going to be switching to a Wednesday schedule. Same time, dentist o'clock, haha, aka 2:30, haha, get it, 2:30? But Wednesdays at 2:30 p.m. Eastern. You can still catch Echo Live every week for the rest of the year. We're pretty excited to be continuing doing really fun demonstrations and experiments. So Maureen, if you are enjoying these programs and there's something we haven't talked about yet that you want us to cover, an experiment you want us to try, or something you've always been curious about, let us know. Send us a message. Tell us in the comments. We'd love to bring you episodes and demonstrations about things that you are interested in, because I'm not out of ideas yet, but I'd love to talk about something that you are excited about too. A couple people starting to tune in or kind of chime in. Jasmine thinks that ice cream is a liquid. And that's a really good answer, I think, right? Because if you have your ice cream sitting in a cup, right, especially that soft serve, it will start to take the shape of its container, which is certainly a property of a liquid. But it doesn't necessarily flow at all times, right? Especially not when we're talking about that hard packed stuff. So just like when we talked about making slime, ice cream is one of those really interesting states of matter. Maybe not necessarily strictly a liquid, but not strictly a solid either. If it was solid like a rock, it wouldn't make a very good treat, right? It'd probably hurt your teeth, be pretty difficult to eat. And so the goal here is to do some chemistry to kind of manipulate our solid, like our sugar ingredients, and our liquid ingredients like our dairy products and our vanilla, and turn it into some sort of semi-solid that's nice and creamy and fluffy and delicious to eat. So we're going to start our experiment here. You'll also need something to make your ice cream in. And the best way to make ice cream at home is actually by making it in one of these sealable plastic bags. You'll need two sizes, one that's slightly larger than the other, so you can place actually one inside the other. So you could use a quart size and a gallon size Ziploc bag like I'm doing, or you could use a sandwich size bag with a quart size bag. As long as they'll fit inside each other with a little bit of wiggle room, then you'll be perfectly good to go. Now the recipe that I'm following, let me try to change my slide here. Maybe not. The recipe that I'm following, I'll show it to you because it's a couple slides down for me. But the recipe that I'm following can obviously be adapted. I'd say that this is enough ice cream that I'm going to be making in this bag for at least 4 people. If you want to make more ice cream, you can make more ice cream. If you want to make less ice cream, you just cut the ingredients in half, maybe would be a good place to start. So we're actually going to start with our big Ziploc bag, our gallon size in this case. And what we're going to do is we're going to put about 4 cups of ice into this bag. Now ice is definitely a solid. Now I have a big bag of ice over here. Trying not to spill it everywhere, but the nice thing about ice is that it'll melt and then it'll eventually evaporate, right? Beautiful things about our states of matter. All right, so we want approximately 4 cups of ice. It doesn't have to be a perfect amount because we're actually not going to be eating this. You don't have to worry too much about this ice and what's going into your larger bag. We'll talk about why. But now I've got about 4 cups of ice in here. Solid water, right? Definitely a solid, this stuff. There's definitely no wiggle room between ice being a liquid and a solid, at least not the way we have it right now. And then all we're going to do is take that coarsely ground salt, or rock salt if you have it, works even better for this part of our experiment. We're just going to sprinkle a fair amount inside the bag to add these two together. Now, if you're using measuring cups, you would add about a 1/4 cup of rock salt or coarsely ground salt. The bigger chunks that you have, the better. And we're just going to kind of shake it around. Get all that salt to kind of start mixing with our water there. We're then going to seal the bag nice and tight, and then we're going to set this off to the side. All right, bag 1 is pretty much complete, and we'll come back to that one in just a minute. Now, inside our smaller bag is going to go our, there it is, our ice cream mixture, our ingredients that we're actually going to be eating. I like to take the bag and kind of place it in something since we're going to be pouring liquids down inside here. I like to start off with it inside something like a cup, or a big measuring cup like this would work just great, just so it doesn't fall over while we're adding our variety of things here. So we first are going to add 1 cup of whole milk. And again, I said you can change this recipe, but we're basically creating half and half. So I'm going to be adding 1 cup of whole milk and 1 cup of heavy whipping cream. If you were to substitute this, right, it's half and half. And so you would either do all half and half. You could do 2 whole cups of half and half. If you're trying to cut the recipe down, you could do 1 cup of half and half. But we basically want to create half and half. So 1 cup whole milk, pour that into our bag. And see, the cup is already coming in handy here. And then 1 cup of our heavy whipping cream. Should have taken off my little tabs here before our program, but that's okay. Now this stuff is much thicker, definitely still a liquid, but definitely much thicker than our whole milk was. Now, if your cup is small like mine, make sure that when you pour it in, everything is staying in the bag. We don't want to lose any of our ingredients here because there's no fun in spilled ice cream. So we definitely want to keep all of it, or as much as possible, inside our quart-sized bag here. The next thing we're going to add is 1/4 cup of sugar, but you can definitely add less sugar if you think that sounds like a little bit too much, especially parents out there. You can always substitute things like fruits that have natural sugars in order to help sweeten up your ice cream as well. We're just going to add our 1/4 cup of sugar there. And you'll notice that I'm not really mixing anything just yet, at least, but we'll get to that. Now, the last thing we're going to add to this mixture here is some vanilla extract. You only need about a teaspoon for this amount of ice cream. That's maybe 2 drops of this vanilla extract. I'm choosing to make vanilla ice cream, but you can make whatever flavor ice cream you like. You could stir in chocolate syrup or cocoa powder to make yourself chocolate ice cream. You could add maybe bits of cereal or chocolate chips if that's your favorite flavor of ice cream. The best part about this is that as long as you have the appropriate base ingredients, our half and half mixture of whole milk and whipping cream, you're going to have a pretty delicious ice cream mixture. Now we're going to seal this quart-sized bag. The important thing to do when you get to this step is you are going to squeeze out most of the air, but not all. We actually do want to leave some air inside this bag, and we definitely want to make sure it's all the way sealed. You can see I keep going back and forth, making sure that there's no gap here. This bag is acting kind of funny. So I'm sealing out most of the air, but not all of the air. The air is going to help get trapped inside our ice cream. The more air you're able to leave inside the bag, I might even choose to leave a little bit more. The more air you're able to leave inside there, the fluffier and creamier your ice cream is going to get when we start off our next step. Now, in our bag that we've set to the side, we now have a really, really cold bag of almost kind of like a slushy, salty ice mixture. We're going to open that bag back up, place down our ice cream mixture inside. Once you do that, if you notice that your bag still has a lot of extra space and you could definitely fit some more ice in there, you can go ahead. Remember that the ice, we're not going to eat it. And so the amount of ice really doesn't matter as long as there's enough to kind of coat your entire bag of ice cream. It's going to help to super cool it. Getting 1 more scoop of ice here. All right. I only spilled a lot of ice cubes on the ground just now, but that's okay. All right. We can add in our ice cubes, maybe even just a little bit more of our coarse salt. And then the most fun, but certainly the hardest step of this experiment is to start to shake our mixture. Basically what we're doing is we're trying to solidify that mixture of milk down inside the inside bag. Now this bag is going to be really, really cold. And so you could either take a pair of gloves, maybe your winter gloves if you're starting to think about your fall clothing, starting to get those out. You can either hold onto this bag with the gloves. You definitely won't want to hold onto it with your bare hands. Or you can take something like a dish towel or a cloth and you can just wrap it around. That way you have a good grip and you are insulating your hands from the mixture inside. Now, when I do this, I like to grab onto the top of my milk mixture bag inside there just to make sure that I'm not going to shake it open, because you are going to have to shake this really hard for about 5 straight minutes. So I'm going to get it started, and then I don't think you want to watch me do this for 5 minutes. So I've got kind of a surprise guest speaker for us. Now I can feel just how cold this bag is. And the weird thing about it is it's actually much colder than the ice that I had initially put in. If you're going to make this ice cream at home, I highly recommend getting a team of ice cream shakers, people who might want to enjoy your ice cream with you. That way you can take turns shaking the bag, because we're pretty much going to have to shake it nonstop for about 5 to 7 minutes. And so I said I have a guest speaker here, but don't get your hopes up too high. It's not someone you haven't met before. This is actually just a recording I made earlier so that I can spend some time shaking this bag for the next few minutes while we talk about the science of what's happening right here inside the bag. So let's go over and take a look. That's me, but our computer sound is not on. All right, here we go. All right, while live me, technical difficulties. I think pre-recorded Anna is having a little bit of trouble here, but let's go ahead and try that again. Go ahead and stop my share. Now, inside our bag, thankfully, it's already starting to freeze, but we definitely want to start to agitate it pretty soon. So let me try to get my video going here. All right, well, best laid plans, right? I thought of everything in advance today. Let's try this one more time. While Live Me works on that bag of ice cream and is doing a great job shaking it up. Wow, you guys, it does not want to play my video for some reason. All right, I'm going to start to shake the bag here. And since I don't have a team, I think I'm going to take a break every 15 seconds or so and talk about a little bit of science at a time. The cool thing that's happening inside this bag is that the salt is actually lowering the temperature that it takes in order for the ice to turn into a solid. Yourself, well, why is that, right? Why does adding salt make the bag colder? We haven't really done anything, right? If anything, it's sitting out in an open room, so shouldn't the temperature be increasing? Shouldn't it be coming up? But unfortunately, what's happening is actually pretty cool. Since salt is an ion, it has this unique ability in order to interfere with the crystalline structure of the water molecules that would normally turn it into ice. So in the top diagram here, we have molecules of pure water, or H2O. When they reach freezing point, they arrange themselves very neatly into this perfect crystalline structure. Oxygens touching hydrogens, hydrogens touching oxygens. It is a perfect system out in nature. But when we have a solution, something that is not made of pure water, something that is instead made of water with other substances inside it, say like salt, which we can imagine in this diagram is something like these orange molecules, those orange molecules start to interfere with this structure. Give me a little bit of time to shake here. Whew. Now, when this happens, right, the water has to get colder. It takes a lot more energy to freeze a solution than it does to freeze a pure water or pure solvent or substance. Thank you to Jasmine, who's helping me out in the chat with a shake, 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 shake your ice cream, shake your ice cream. By now, our mixture has gotten so cold that it's actually past the freezing point of water and starting to get down into the freezing point of the different fats and proteins that make up whole milk and whipping cream. Of course, the temperature of those is much lower, right? So in theory, we could have taken this bag of ice cream mixture, we could have put it in the freezer, right? But that would just turn it into a frozen solid. And we said we don't actually want that. By keeping it in this kind of in-between state of frozen, but not frozen, we're allowing the water inside the bag or the water inside our whole milk to start freezing at the same time as we are keeping the proteins in a liquid state. Now, think to yourself, I've got a question for you out in the audience. Where else do we see this mixture of salt out in the real world? How does that help us in the real world when, say, we're trying to prevent something from freezing? Let me know in the chat. I'll give you a hint. If you live here in Michigan, you've probably seen this a lot. You've actually probably seen this process out in action all the time. If you live somewhere where you don't necessarily have a winter season that's very cold and very icy, maybe you haven't seen this before, but what do we normally use salt for in the winter time here in Michigan? Whew. All right. Thankfully, our mixture is just about done. Now, if you live here in Michigan, where I know a lot of you do live, you've actually seen this scientific process out in the real world there to keep us safe. Maybe you've seen one of these salt trucks that drives around sprinkling a type of mixture of salt onto the roads. Now, why would that come in handy, right? Why would we need salt on the roads? But it's for the exact process that we just saw with our ice cream, right? If we make water freeze at a lower temperature before 30 or below 32 degrees, right? We can keep the roads safe for longer. In the case of the salt that we put inside this bag, this lowered the freezing point of water to about 0 degrees Fahrenheit instead of 32 degrees Fahrenheit. And here in the wintertime, it's about 32 degrees or less most of winter. It's 32 degrees or less most of the time. But it's not 0 degrees or less as often, right? And so this is really helpful, and it's actually there to keep us safe. Now let's go ahead and let's take a look at our mixture here inside the bag. We can go ahead, we can take the bag out. I'm gonna seal off my salty ice mixture and set that back off to the side because, like we said, we are not gonna eat that. That would taste really gross. And before we open our mixture of ice cream, you're either going to want to run this whole bag without opening it, run the whole bag underneath the cold water of your sink, or at least do a really good job wiping it off. The only reason we're doing this, right, is that this bag is covered in that salt mixture, which is really not going to taste very good if you got it in your mouth. And so we've wiped it off. And now you can see if I open the bag, it's certainly not a liquid anymore. It can almost stand up entirely on its own. If I take my handy dandy spoon here, take a little bit and scoop it out, you can see that in maybe a little more than 5 minutes, since I was doing the shaking and the science at the same time. When you do this at home, right, take turns with your friends or take breaks like I did, and it maybe will take you about 5 to 7 minutes to make yourself your own delicious vanilla ice cream treat, right? You could try this at home. It's super easy. You probably have all of these things But here at the Science Center, oh, that's weird. Here at my side, we like to do things a little bit differently. You can do this at home because it takes all ingredients that you probably have at home or could really easily get at the grocery store. But of course, here at the Science Center, we like to do things a little bit more extreme. So instead of using our rock salt and ice mixture in order to freeze our ingredients, this time around, we're going to take some of that super cold liquid nitrogen. This one will be a little bit easier on me. I won't have to do as much shaking, just a little bit of stirring once we get our ingredients all mixed together. But the recipe is the same. We're going to take equal parts of whole milk. We choose whole milk because it has a lot of those fats and proteins in it that are a little bit more difficult to freeze. 2% milk has a lot more water in it. And so if you try to use 2% milk, it'll probably work, but you might end up with a little bit of an icier mixture. All right, so we've got our half and half mixture of whole milk and whipping cream. Now we need our sugar. And last but not least, since we're not using the salt this time, just a little bit, couple drops of our vanilla extract for flavor. And then this one, like we said, is a whole lot more low maintenance. I won't have to do quite as much, but safety first always when you're working with something as cold as liquid nitrogen. We said that our bag of ice got down to about 0 degrees Fahrenheit, and so we didn't want to touch that with our bare hands. But this stuff is almost negative 300 degrees Fahrenheit. It is very, very cold stuff. So we're just going to take a good amount of it, and we're just going to pour it right into the bowl. We're going to give that just a moment. We don't want it to freeze solid, but what we're letting happen right now is we're dropping the temperature of our milk mixture. It will start to freeze the water molecules from the whole milk, but leaving those protein and fat molecules from our milk almost in their liquid state, which gives us, again, a very nice, very frosty bit of liquid nitrogen ice cream. And maybe you've seen this at the mall. It's becoming more and more common, but of course you can't buy liquid nitrogen at the grocery store. You have to have a big fancy container to hold on to it. This is what we call a thermos, but you can't buy it in a thermos. You have to buy it in something called a dewar, which will keep it at the right temperature to keep nitrogen a liquid long enough for you to use it. And then of course, now we've got another big, nice, creamy, fluffy pile of delicious vanilla ice cream. Ta-da! Hi, Evan from Texas. I'm sorry you were busy with school, but you'll have to rewind and watch because today we have been making ice cream. You can make it at home, even without liquid nitrogen. That is just about all the time we have together today. Of course, this is a great time, as always, to thank the sponsors of the Michigan Science Center, like Ford and Denso. They've been allowing us to bring you these programs for ever since March and through the rest of this year. This is the recipe for ice cream in a bag. So all you'll need, again, is that whole milk, whipping cream, sugar, vanilla, and then for your bag, you'll need the 4 cups of ice and your 1/4 cup of salt. So again, big thank you to Ford and Denso. Waiting for my slide to change here. Our PowerPoint is just acting up today, you guys. Well, we have a couple exciting announcements, but I guess even without my slide, I'll let you know. Later today, we are doing a live career interview with the help of the STEMinista project. You can find it on the Michigan Science Center's Facebook page. You can find it on our YouTube channel and the STEMinista project, their Facebook page. We're going to be interviewing a STEMinista role model, a woman in STEM, and she'll be interviewed by our STEMinista project community manager. And so you won't want to miss it. It'll be live today at 4:00 p.m. And then the other announcement has to do with what I said at the beginning of this program, that we are not done with Echo Live, even though fall is coming. We are continuing after fall starts officially. And so maybe you know what day that is, but after fall starts officially, we are switching to a Wednesday program schedule. So we'll continue seeing you all here Wednesdays at 2:30. We hope you'll continue tuning in. Let us know if there's a topic we haven't covered just yet that you'd like us to talk about. And with that, thanks everybody for joining in.